Paralleling transformers involves connecting two or more transformers together to increase the overall capacity of a power system. This is often done when the existing transformer is insufficient to meet the growing load demands or to provide redundancy in case of a transformer failure. The information here describes the procedure for paralleling two identical transformers. Firstly, it is important to observe safety precautions. Ensure all personnel are qualified and have the necessary training. Wear appropriate personal protective equipment. Verify that all equipment is grounded and in good working order. Ensure that the area is well ventilated and free from combustible materials. The materials you'll need are two identical transformers, a voltmeter, an ammeter, a phase rotation meter, control wiring and connecting cables. 1. Preparation. Check transformer data. Verify that the transformers are identical in terms of voltage, power rating, impedance, and phase connections. 2. Test insulation. Perform an insulation resistance test on both transformers to ensure that they are free from insulation faults. Secondly, establish phase rotation. 1. Determine phase sequence. Use a phase rotation meter to determine the phase sequence of the primary power source. 2. Match transformer connections. Connect the primary terminals of the transformers according to the determined phase sequence. Thirdly, connect transformers. 1. Connect primary windings. Connect the primary terminals of the transformers in parallel. 2. Connect secondary windings. Connect the secondary terminals of the transformers in parallel, ensuring that the polarities match, for example, lone to lone, L2 to L2, L3 to L3. Fourthly, synchronize transformers. 1. Energize primary windings. Apply power to the transformer primary. 2. Monitor voltage and frequency. Use a voltmeter to monitor the voltage on the secondary terminals and an ammeter to monitor the circulating current. 3. Adjust transformer taps. Adjust the taps on one of the transformers until the secondary voltages are nearly equal. 4. Monitor circulating current. The circulating current should be minimal, typically less than 5% of full load current. Fifthly, parallel operation. 1. Close paralleling breaker. Once the transformers are synchronized, close the paralleling breaker to connect the secondary windings together. 2. Monitor secondary voltage and current. Verify that the secondary voltage and current are within the specified limits. Sixthly, load test. 1. Apply load. Gradually apply a load to the transformers and monitor the voltage, current, and temperature. 2. Adjust voltage regulation. If necessary, adjust the voltage regulation of the transformers to maintain consistent output voltage. Seventhly, protection and controls. 1. Install protective devices. Install appropriate protective devices such as overcurrent, overload, and differential protection to ensure safe operation. 2. Commission controls. Set up appropriate control systems for monitoring and controlling the transformers. Consider these additional notes. It is recommended to refer to the manufacturer's instructions for specific details and requirements. Proper grounding and bonding are essential for safety and proper operation. Regular maintenance and testing are necessary to ensure the reliability and safety of the parallel transformers. Paralleling transformers improperly can result in equipment damage or electrical hazards. It is crucial to follow all safety precautions and procedures carefully. If you are not qualified or experienced in electrical work, seek professional assistance. A more detailed breakdown of these steps follows. First, the safety precautions in paralleling transformers are paramount. Qualified personnel must undertake the procedure, and they must be thoroughly trained in all aspects of transformer operation and safety protocols. They should be adept at recognizing potential hazards and responding appropriately. Proper personal protective equipment, or PPE, including but not limited to insulated gloves, safety glasses, and appropriate clothing, is mandatory. This equipment minimizes the risk of electrical shock, burns, and other injuries. Before commencing any work, it is crucial to verify that all equipment, including the transformers, grounding systems, and testing instruments, are in good working order and properly grounded. Grounding ensures a safe path for fault currents, reducing the risk of electrical hazards. The work area should be well ventilated to prevent the accumulation of flammable gases or vapors. Additionally, the area must be free from combustible materials that could pose a fire hazard. These measures collectively create a safe working environment for paralleling transformers. Secondly, the required materials must meet industry standards for transformer paralleling. Two identical transformers are the foundation of the paralleling process. These transformers must have the same voltage ratio, kVA rating, impedance, and phase displacement to ensure proper operation. A voltmeter is essential for measuring voltage levels at various points in the circuit, enabling accurate adjustments and synchronization. An ammeter is used to measure current flow, particularly the circulating current between the transformers, which should be minimized. A phase rotation meter is crucial for determining the phase sequence of the primary power source and ensuring that the transformers are connected correctly to avoid phase opposition. Control wiring is necessary for connecting the transformers to the control and protection systems, enabling remote monitoring and control. Finally, connecting cables must be appropriately sized and insulated to handle the expected current and voltage levels safely. Thirdly, the preliminary steps for transformer paralleling are critical for ensuring compatibility and safety. Begin by thoroughly checking the transformer data to confirm that the transformers are indeed identical in terms of voltage ratio, kVA rating, impedance, and phase connections. Any discrepancies can lead to circulating currents and potential damage. Perform an insulation resistance test on both transformers using a megometer. This test verifies that the insulation is intact and free from faults, preventing short circuits and ground faults. The insulation resistance should meet or exceed the manufacturer's specifications. Fourthly, establishing the correct phase rotation is crucial for avoiding destructive circulating currents. Use a phase rotation meter to determine the phase sequence of the primary power source. The meter will indicate whether the phases are in the correct order, typically A, B, C or 1, 2, 3. Connect the primary terminals of the transformers according to the determined phase sequence. Ensure that the corresponding phases are connected together, for example A to A, B to B, and C to C. Incorrect phase connections can result in a phase opposition, leading to a short circuit and potential damage. Fifthly, physically connecting the transformers involves careful attention to polarity and terminal connections. Connect the primary terminals of the transformers in parallel, ensuring that the corresponding terminals are connected together. Use appropriately sized and insulated cables to handle the primary current. Connect the secondary terminals of the transformers in parallel, paying close attention to polarity. The polarities must match, for example, lone to lone, L2 to L2, and L3 to L3. Incorrect polarity connections will result in a short circuit and potential damage. Verify the connections with a multimeter to ensure the polarities are correct. Sixthly, synchronizing the transformers is a critical step in ensuring proper operation and minimizing circulating currents. Apply power to the transformer primaries, energizing the transformers. Use a voltmeter to monitor the voltage and the secondary terminals of both transformers. The voltages should be nearly equal. Use an ammeter to monitor the circulating current between the transformers. The circulating current should be minimal, typically less than 5% of the full load current. Adjust the tapt on one of the transformers until the secondary voltages are nearly equal. This minimizes the voltage difference and reduces the circulating current. Seventhly, parallel operation involves closing the paralleling breaker and verifying the system's performance under a load. Once the transformers are synchronized, close the paralleling breaker to connect the secondary windings together. This completes the parallel connection. Monitor the secondary voltage and current to ensure they are within the specified limits. The voltage should be stable, and the current should be shared proportionally between the transformers. Apply a load to the transformers gradually, monitoring the voltage, current, and temperature of each transformer. The voltage should remain stable, and the current should be shared proportionally. Adjust the voltage regulation of the transformers, if necessary, to maintain a consistent output voltage under varying load conditions. Eighthly, protection and controls are essential for ensuring the safe and reliable operation of parallel transformers. Install appropriate protective devices such as overcurrent relays, overload relays, and differential relays to protect the transformers from faults and overloads. Set up appropriate control systems for monitoring and controlling the transformers. These systems should include alarms for abnormal conditions such as overvoltage, overcurrent, and high temperature. The control systems should also allow for remote monitoring and control of the transformers. Ninthly, additional notes provide important considerations for long-term operation and maintenance. Refer to the manufacturer's instructions for specific details and requirements regarding the transformers. The manufacturer's instructions provide valuable information on installation, operation, and maintenance. Ensure proper grounding and bonding of all equipment to provide a safe path for fault currents and prevent electrical hazards. Regular maintenance and testing are necessary to ensure the reliability and safety of the parallel transformers. This includes insulation resistance testing, turns ratio testing, and oil analysis. Finally, always exercise caution when paralleling transformers, as improper procedures can result in equipment damage or electrical hazards. It is crucial to follow all safety precautions and procedures carefully. If you are not qualified or experienced in electrical work, seek professional assistance. Paralleling transformers requires a thorough understanding of electrical principles and safety practices. The following considerations are often needed for paralleling transformers. Firstly, impedance matching. The transformers being paralleled should have nearly equal impedance values. Impedance is the opposition to the flow of alternating current and is expressed in percentage or per unit values. If the impedances are significantly different, the transformers will not share the load equally. The transformer with a lower impedance will carry a larger share of the load, potentially leading to overloading and premature failure. The impedance values are typically found in the transformer nameplates. Secondly, voltage ratio. The transformers must have identical voltage ratios. The voltage ratio is the ratio of the primary voltage to the secondary voltage. If the voltage ratios are not the same, a circulating current will flow between the transformers, even when no external load is connected. This circulating current can cause excessive heating and reduce the efficiency of the system. The voltage ratios are also typically found on the transformer nameplates. Thirdly, tap settings. Even if the voltage ratios are nominally the same, slight differences in tap settings can cause circulating current. Tap settings allow for adjustments to the voltage ratio to compensate for voltage drops or variations in the supply voltage. Before paralleling transformers, ensure that the tap settings are identical on both transformers. Fourthly, phase displacement. Transformers can have different phase displacements depending on their winding connections. The phase displacement is the angular difference between the primary and secondary voltages. For example, a delta Y transformer has a 30-degree phase displacement. Transformers being paralleled must have the same phase displacement. If the phase displacements are different, the voltages will not be in phase, and a large circulating current will flow. Fifthly, winding connections. The winding connections of the transformers must be compatible. For example, you cannot parallel a delta-delta transformer with a Y-Y transformer. The winding connections determine the phase displacement and voltage and current relationships. Sixthly, circulating current. As mentioned earlier, circulating current is a current that flows between the transformers when they are connected in parallel, even when no external load is connected. Circulating current is caused by differences in voltage ratio, impedance, or phase displacement. Excessive circulating current can cause heating, reduce efficiency, and potentially damage the transformers. The circulating current should be minimized by careful selection and matching of transformers. Seventhly, load sharing. The transformers should share the load proportionally to their kVA ratings. For example, if you are paralleling a 500 kVA transformer with a 750 kVA transformer, The 750 kVA transformer should carry 60% of the load, and the 500 kVA transformer should carry 40% of the load. Unequal load sharing can lead to overloading of one transformer and underutilization of the other. Eighthly, protection. Parallel transformers require careful protection to prevent damage from faults or overloads. Overcurrent protection should be provided for each transformer to protect against overloads and short circuits. Differential protection is often used to detect faults within the transformer windings. Ninthly, switching. The switching sequence for parallel transformers is important to avoid voltage surges and circulating currents. Typically, one transformer is energized first, and then the second transformer is synchronized to the first before being connected in parallel. Automatic synchronizing equipment can be used to simplify this process. Tenthly, grounding. Proper grounding is essential for the safety and reliable operation of parallel transformers. The transformer neutral should be grounded to provide a low impedance path for fault currents. The grounding system should be designed to minimize ground potential rise and prevent touch potential hazards. 11thly, harmonics. Harmonics are distortions in the voltage and current waveforms that can cause problems in electrical systems. Transformers can generate harmonics, especially when loaded nonlinearly. When paralleling transformers, it is important to consider the potential impact of harmonics and take steps to mitigate them. This may involve using harmonic filters or selecting transformers with lower harmonic distortion. 12thly, monitoring. Parallel transformers should be monitored to ensure proper operation and detect any abnormalities. Monitoring parameters may include voltage, current, temperature, oil level, and gas pressure. Alarms should be provided to alert operators to any potential problems. 13thly, maintenance. Parallel transformers require regular maintenance to ensure their continued reliable operation. Maintenance activities may include inspecting connections, testing insulation, changing oil, and performing load tap changer maintenance. 14thly, redundancy. Paralleling transformers can provide redundancy, meaning that if one transformer fails, the other transformer can continue to supply power to the load. This can improve the reliability of the electrical system. However, the remaining transformer must have sufficient capacity to carry the entire load. 15thly, future expansion. When paralleling transformers, it is important to consider future expansion. The transformers should be sized to accommodate future load growth. It may also be necessary to upgrade the switchgear and protection systems to handle the increased capacity. 16thly, cost. The cost of paralleling transformers can be significant. The cost includes the cost of the transformers, switchgear, protection systems, and installation. A cost-benefit analysis should be performed to determine if paralleling transformers is the most cost-effective solution. 17thly, regulations and standards. Paralleling transformers must comply with all applicable regulations and standards. These may include national electrical codes, utility requirements, and industry standards. 18thly, manufacturer's recommendations. Always follow the manufacturer's recommendations for paralleling transformers. The manufacturer's recommendations provide valuable information on installation, operation, and maintenance. The steps here offer a general guide. Always prioritize safety and consult with qualified professionals for specific applications. Remember that working with electrical equipment can be dangerous. Always follow safety precautions and seek professional assistance if you are not qualified.